In this video, we'll look at question 8 to question 14 till the end of the test. A little bit of probability here. In question 8, we're given a fair-sided dice and we're given the net of it. We're asked what number will be opposite the number 7. Here's the number 7. If we fold the 8 down, it'll be along the side, as will number 3, which means that 1 would flip underneath. So 1 has to be opposite 7. The die is rolled once. Find the probability that the number is greater than 6. So the probability of greater than 6 is equal to, there's 6 sides. How many of them are greater than 6? It's not a normal dice, we just have a 7 and an 8. Just double check. We have a 1, a 3, a 4 and a 5. So just 2 over 6. They're the only ones that are greater than 6. You don't need to simplify it to a third. The dice is rolled 60 times. So we're going to multiply the probability by 60 to get the frequency, or how many times. And we're looking for odd number. So we go back to the diagram. How many of them are odd? 1, 3, 5, 7. 4 is not and 8 is not. So 4 out of 6 times 60 would be 40 times. For part C, A, B and C were all worth 10 joined together. And then part D, we're given this table. The following 3 terms are used when discussing experiment and probability: outcome, sample space and event, and we're just asked to match them off. Be really careful and take your time with the first one. So let's read it carefully. The set of all the possible outcomes. Well, that can't be the outcome. It can't be the event. It has to be the sample space. Sample space in here. One possible result, well, that would have to be an event or an outcome. And then a subset of the sample space, a collection or one or more outcomes. There's a kind of giveaway. The word outcomes there means that this one can't be outcome. This has to be event. And this is an outcome. So sample space, outcome and event are the 3 answers for part D. Part D was worth 5, given 15 for this question. Question 9. There was 20 marks for question 9. It's another coin flip question. Probability. The diagram is given underneath this, so we just asked to fill in the missing letters, H or T, heads or tails, the 5 missing outcomes, and the number of heads in each of the outcomes. This is something that you should have learnt off in first year. If you know these probabilities off by heart, this is the easiest question you're ever going to get. So let's have a look at the table you're given. Here it is. So head, head, head at the top always, tail, tail, tail at the bottom, and then a combination of in between. So head, head, tail, you can see here, H, H, T. Then we're going to have head, tail, head, which is given. Then head, tail, tail. Then we're going down to the tail to begin, tail, head. And we're going to have heads or tails. So the first one's given, THH, then THT. Then we're on this one, TTH. And then TTT down the bottom. Good revision for the first year exam. This question normally comes up. So the number of heads, it's quite specific here. The number of heads we're asked for. You know that one outcome is going to have 3 heads. One outcome is going to have 3 tails. And then the other 6 will be divided in 3 between 2 heads, 1 tail, and 2 tails, 1 head. So when you learn this probability off in elements, it becomes a little bit easier when you get to here. So just be careful filling them in. This one has 2 heads. This one has 1. This one has 2 heads. This one has 1. This one has 1. And this one has none. And does that match off with our probabilities? 3 tails will be the null. 3 heads will be the 3. and then we should have 2 1s and 2 2s. There's the 3 and the 0. So 3 2s and 3 1s. I said 2. I think 3 2s, 3 of each, 3 2 heads and 3 1 heads. So there's my 3 2s, there's my 3 1s. And then part B, a nice easy question to follow, worth 5 marks. How many have none heads? 1. How many have 1 head? We saw it was 3. 3 had 2 and 1 had 3, giving 8 as the total. And then she flips a coin 8 times. Each time she can get heads or tails. Write down the number of outcomes that have no heads. And if she flips the same coin 8 times, it's going to have a head or a tail, repeating across in this direction, head or tail each time. So many of them will have just, there's one possibility we could get loads of heads all the way, and there's a possibility that we could get tails all the way, and then like the table above, the combinations in between. So the number of outcomes that have no heads will just be the one down the bottom. That could be tail, 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 going that way. So 1 is the answer here. I'm just flipping back up to this. I hope you're seeing that we didn't actually write in the probabilities, we just wrote in the totals. Don't make that mistake on an exam. Part 2, we're asked to work out the number of outcomes that have exactly 1 head. She's flipping a coin 8 times. Let's just imagine this is the coin 8 times. So for it to have 1 head, it could end up in this position here, position 1. These will all be tails. That's one option. So it can actually happen in any of the positions, and the rest will be tails, and that could happen 8 times. Head followed by 7 tails in 8 different positions. So 8 of the outcomes would have exactly 1 head. For it to have 7 tails, if it only has 1 head. And then the last part of this question, work out the total number of outcomes. We saw when she flipped it 3 times, there was 8. Where does that come from? 2 to the power of 3, because there's 2 outcomes equally likely. 8, so 2 to the power of 8, if she flips it 8 times, and 2 to the power of 8 is 256. Tricky enough probability question here. In question 10, we have parts A, B, and C. A is worth 5, B and C are worth 10. And we're asked to work out the circumference of a circle, and we're told diameter. Circumference of a circle is the distance around the outside, 2 pi r. If you don't know the formula, you look it up in the tables, but this is circumference. So 2 multiply, it doesn't say what to use pi as, use the pi on the calculator. Multiplied by r, which would be 4 if the diameter is 8. 2 pi r is also the diameter times pi, if you so wish. But this is the formula we're given, so this is the one we normally use. 2 by pi by r. Your calculator will give you 8 pi. And then you're going to have to change it to decimals. And the decimal it's giving me, correct in 1 decimal place, 25.1. And we're dealing with centimeters. Now we have a rubber track for a toy digger, and it goes around 4 circular wheels of diameter 8 as shown. Calculate the length of the rubber track that goes around the 4 wheels. That needs to be, let's have a look here. We have, if we take this point here and we say that that's half a circle, and the same would happen at this end. We have 2 pi r plus 2 bits in the middle, which how many radiuses have we got in between? We have 1, 2, 3, 4, 5, 6 radiuses, which is equal to 3 diameters, whichever way you want to look at it. So we have 3 diameters. Diameter is 8, so 3 times 8. So we have the 25.1, and don't forget now we have them top and bottom here. So we're going to need to add 3 times 8 twice, are we? Because we also have, obviously it's not going through the middle, we have the top and bottom. So that's 25.1 plus 24 plus 24, 48 and 25 is 73.1 centimeters for the length of the rubber track in part B. And then part C. Part C, every time the wheels turn fully, the digger travels a distance equal to one wheel's circumference. Well, that distance, one wheel circumference, was 25.1. So work out how many times each wheel will turn fully when the digger travels a distance equal to the length of its rubber track. That was the previous part, the length of the rubber track. We got to be 73.1. So we want to know how many times each wheel turns fully when it travels this distance of 73.1. Well, when it turns around twice, it's going to be 50.2, 25.1 by 2. 3 times would be 75, so just slightly less than 3. So we'd have to divide the 73.1 by the 25.1 to find out how many times it turns. It's going to be 2 point something. It's giving me 2.9 turns, and if I don't read the question carefully, I may lose a mark. I've underlined it here, fully, so the full turns are actually only 2 full turns, just slightly less than 3. So I will jot that down underneath, 2 full turns, nearly 3. That's the end of question 10. Question 11, 10-minute question in the diagram below. And marks wise for this, there were 15 for A and B combined. So in the diagram below, two of the sides have a length of S. What I would do straight away is I'd complete this little square here, that's SS. And then the other one is 10 by 6, so the total is 10 by 6, which is 60. And this bit in here is S by S, which is S squared. And what are we asked to do here? We're asked to find a formula in algebra for the area of the shape in terms of S. So the whole thing will be 60, and we'd have to take away the S squared. And that's the formula here for area, so we'll write down A equals 60 minus S squared. And then show or explain why the perimeter is always 32 no matter what the value of S. How interesting is that? So let's show why the perimeter is always 32. So we're going to have perimeter, it's going to be equal to 10 plus 6. Now we just need to get the rest of the sides. This one on top here, it's going to be 10 take away the S here. So no matter what value of S, we can just call it S. So that's plus 10 minus S. You can see the S's are going to cancel here. So let me just move this out. So we're going perimeter, we're going in this direction. We've included 10 minus S, so we have to add this S and this S. So plus S plus S. And then the last bit of the perimeter is this guy, which is 6 minus S. So plus 6 minus S. So we're going to get 10 and 6 and 10 and 6. We're going to get 20 and 12, 32. And then what happens with all my S's? We're going to get plus 2S minus 2S. I think that's a nice way to show it. So the perimeter is equal to 32, as S will always cancel. That's question 11. Question 12, 2019, was a proof, which you don't have to do after 2019 was the last exam before the crazy years, but it was the last year that had proofs on it. Prove that each exterior angle of a triangle is equal to the sum of the interior opposite angles. We have to come up with a diagram. I'm going to create a triangle. ABC, so that's what we'll say we're given, this triangle ABC. We can have our construction on it here too. Given triangle ABC, and we could say extended to D. That's what you'd write in here to prove. Let's call this angle A, angle B, and angle C to prove each exterior angle. So the exterior angle here we'll call D. So let's prove angle D is equal to the sum of the two interior opposites, angle A plus angle B. And the proof here, which I'll do up here, we can say that angle A plus angle B plus angle C is equal to 180. Why? Three angles in a triangle. We can shorten it down with some symbols. We can also say that angle C plus angle D is equal to 180. Why? They form a straight line. And even though these are not in the course anymore, if you're watching this video, it is good maths. You need to know this before you start the Cert course. So what are the department at? Well, who knows? Angle C plus angle D. We can equate these two equations because they're both equal to 180. So if both of these things are equal to 180 and they're both equal to each other, and we write them out like this, if we are asked to prove angle D is equal to A plus B, look what happens here. We can cancel our C's because they're on both sides, and we're left with, therefore, angle A plus angle B equals angle D. Quad erat demonstrandum. Happy days. Proof done. Easy marks when you know how to do them. Question 13 was a trick question. What have we got here? We've got the two straight sides. You're all saying immediately we're going to use tan because we've got the two straight sides. We can go through the whole labeling thing if you want. The tan of the angle is equal to opposite. Opposite the angle is 6 over adjacent, which is x. What happens with the x and the tan 20? They swap places, you're telling me. X is equal to 6 divided by tan 20. So we're dividing by tan 20 and multiplying by x. So x, back up to our question, corrected 2 decimal places, is equal to 16.48. And are we given any units? We're not given any units in this question, so I'm just going to write units here. That's part A. Part B was another kind of slimy proof that they threw into this year. Let's have a look at it. You're given a different right angle triangle, and you're asked to prove cos y plus sin y is greater than 1. Now, what can we say here? Let's look at cos y. What is the cos of y? Cos of y is equal to a over h, using your SOHCAHTOA rules, if you want to write it down. So the cos of y, if y is here, adjacent is a, and h is c. We can say the sine of y is equal to O, which is B, over hypotenuse, which is C. And the question is telling us to add them together. So A over C plus B over C is equal to the same denominator. So A plus B over C. And we're also told A plus B is greater than C. So if A plus B is greater than C, we can say that A plus B over C is greater than 1. Q, E, D. And I put a little therefore in here. And that question is complete. Question 14 was area and volume. A cylinder of radius r. Stick it on here. Radius r. And height 10. 10 here. It's melted down and it's made into a cone. So we have the cylinder melted to make a cone, which the volume of a cone is 1/3 pi r squared h. The volume of a cylinder, a V cone, the volume of a cylinder is pi r squared h. So let's work out the volume of this one first. We know that it's losing 10%. We could work out 90% of its volume, but let's just work out volume pi, and we'll equate these things. or actually let's put in the 0.9, 90% of pi times r squared times 10. That's now going to be equal to the volume of the cone. It's the same amount of material, which is a third, times pi, and we're told r is the same, which makes this question easier, times r squared times this new h in this triangle here, which we're asked to work out, which we don't have, so h. So the r squares and the pi's will cancel here, so we're going to get 10 by 0.9, which is 9, times the 3 on the bottom here, so that's 10 by 0.9 by 3 is equal to this h on the right. Works out quite quickly actually. 27 is equal to the new height. You see here the old height was 10, so there's an increase of 17. 27 minus 10 is 17, that's the increase. So the increase is 17, began at 10, multiplied by 100 will give us the percentage increase, which in this case is 170%. And there were 15 marks for question 14, and that completes this paper.